Okay, next thing we need to do, let me quickly just make the new file before we continue so that nothing breaks. Okay, next thing we need to do is get paddle 2 up and running. Now the easy way to do that is we take paddle 1, copy it down here, and we change this to paddle 2. And then of course we need to change these values to be the same values as paddle 2. So quick little tip, if you click on here, you'll see at the top of the screen it also says bookmark control F1. If you click here, it bookmarks this line. Then you can scroll wherever you want to. In our case, we're going down to the draw function to get these 234 and 100. Now if I press F1, pops back to where that bookmark is. Sometimes it does that thing where it selects everything between here and there. It's a bit buggy, but the point is, if you need to get back to a part in the code that you were before, you can do multiples of these, and it'll, like, here's another one, and every time I hit F1 it bounces between the two. Quite handy. Okay, so that's P2, that's its location. I'll get to button up and down in a second. Now we also need to draw using this, which means in our draw function, control O, draw function, we find where we draw paddle 2, and instead of taking hard-coded values, we take p2.x, p2.y. Save. As before, if I run this and it looks exactly the way it did before, it means that I didn't break anything. So 3, 2, 1. Yeah, that looks good. This is exactly where it needs to be. My paddle still moves the way it's supposed to. Okay. Now how do we make paddle 2 move? Back at the top. I could have just done the F1 thing. Back at the top. Now, one would think that paddle 2 would be the up and down reference for the second controller, for player 2. The problem is, in my experience with TIC-80, I've never been able to get it to read a second controller, except for the start button that brings up the menu, but I've been unable to move a second character using a second controller. I don't know if this is a known issue, but we're going to avoid the issue and do a little fun thing by allowing 2 players to share a single controller. So instead of using, I think it was 8 and 9 of up and down for the second controller, we are going to use the A and B buttons on player 1's controller to move the paddle for player 2. In other words, 2 people can play against each other by sharing a controller, which I think is really fun. So Y would be at the top. So let's make the up button Y, which in this case is 7, and the down button A, which is 4. Maybe at this stage I should also, while I'm here, add a btn OK, which is going to be the button that the player uses to action anything that needs actioning. For player 1, this would be probably left, which would be pressing towards them. Remember the comma. Copy this so I don't screw up any spelling. Paste it here. Fix the indentation. For this player, it'll probably be B, which is 5. So you would have up and down on your half of the controller, and then pressing towards yourself will select or launch the ball or whatever we end up using it for later on. Nice thing about Pong, don't have a lot of buttons. Okay, now Control O, go to inputs. We can code player 2's inputs by literally copying and pasting this, which would work. Problem is, then we have separate code running for player 1 and player 2, which means it can introduce the idea of if I make a change on one and forget to change it on the other, one of the controllers, well, one of the players would be different, and that's unfair. So what if we could write a single set of code that handles the movement for a paddle, and then we apply that piece of code to every paddle? We can do that by looping over the paddles and executing the same piece of code for both. So how do we do that? Let's start by encapsulating these two paddles in a list or an array named paddles, following our same format of capital letters because it's a global and we want it to look intimidating. Tab all of this in because it is now inside paddles because I added a brace. It needs to end with a comma, and then paddle 2 indent, and then we end the object with a brace. Why does this not line up? Oh, because this brace is one end, so that needs to be there, that needs to be there, that's there. Okay, now we have an object named paddles. Inside that we have an object named P1, and inside that it has the values. In other words, let's quickly jump back down to our draw function. We now have paddles.p1.x and paddles.p1.y, as well as paddles.p2.x and paddles.p2.y. I know it looks like a lot of typing to do the same stuff, but now I can talk to all paddles at the same time, or I can talk to a specific paddle, or I can read a value from a paddle by using different... Imagine these like addresses. That's the town, that's the street, that's the house number. You don't necessarily need all the detail. If you are in the same town, you don't need to know which town you're in, you only need a street number. If you're in the right street, you don't need to know what street, you only need to know the house number. So depending on the situation, you might not need all this information, but it's easy to read. We know where everything is. It's better if code is understandable than small and simple. If you look at the bottom right, it says here size 1132, that's I think characters, out of 65,536. We have more than enough space. There is no reason for us to be obtusely concise with our descriptions of stuff. So let's utilize that. Okay, this should draw both paddles, but if I try to move them, paddle 1 is going to break because I already have code that reads updates and button presses for paddle 1. We'll get to that in a second. Let's make sure that it at least draws the paddles in the correct location. It does not. Attempt to index a null value global 1. This is line 40. Control G. Line 40. So every time it checks for this button press, I am going to have to do it this way. At least for the two ifs, just so that it'll keep quiet about it. I am well aware of the fact that the code below this, that line, is broken. So if I do actually press the up or down button, it's going to explode. But for the time being, let's just clear this error message so that I don't think it's the same thing happening again, and run. Really? This is now on line 53. Go to 53. Oh, there's another one in updates. This is, to a degree, a viable way of debugging your code. Just hitting run until it stops shouting at you. Line 56, so here. Problem with doing it this way is that I'm not fixing everything. I'm only fixing the parts that the code checks. So this is still going to break. Cool. They're drawn in the right location. That means it's reading the correct value. It's not exploding. But if I press a button, it explodes. So let's quickly run through this and fix all the references. Which is funny because I know what we're doing next, because I have a script. And I know that what I'm doing now is going to be replaced literally within minutes. So at least this is verbose. This illustrates the point that I am adding a whole bunch of stuff that feels like it doesn't do anything, but it does, however, mean that when we do the next step, the amount of code that changes is going to be more dramatic, and the big reveal is going to be more awesome. So, paddle move up and down. Can't move paddle 2 yet, even though I've got the buttons assigned, because there's no code for it. That wasn't now, that's earlier. Okay. Now, because we have paddles as a table, and in that table we have two values, we can do this fun thing in inputs. Paddles up and down, where instead of reading the input for each paddle, we go for, and then we want the index and the paddle in. Here's a new keyword. This is a Lua thing. Pairs of paddles. So what this is going to do is it's going to give me a for loop, and each time the loop repeats, it gives me the next object in paddles as pad, with its key, in other words P1 or P2, as the index in this case. There's also I pairs, which specifically gives you an index value rather than the key that the thing is named, which in our case, I don't think we're actually going to use it, because that is not going to be super important. But then all of this, up to P1 up down, we need to tab in, including the end, because this is now going inside our for loop. And this is going to be, for both paddles, a single paddle. Paddle up, down. Now, instead of talking to paddle 1 directly, we're going to talk to pad and then read its button up, which means the first time this loop runs, we'll be looking at paddle 1, which will be in the value of pad, and it will have its button up, which means we can then move that pad y to pad.y and by pad.speed. And if pad.btn, then pad.y is equal to pad.y plus pad.speed. So for each of the paddles in the value of pad, we look if that paddle's up button is pressed, then we move that paddle. Then if that paddle's down button is pressed, we move that paddle. Okay, then in updates, we can do the same thing. Check whether paddles have left the screen. By the same logic, for I and pad in, all pairs inside paddles, do all of this. Updates. And what we're doing in here is if pad.y is less than 1, then pad.y is equal to 1. Otherwise, else if pad.y plus paddle height stays the same because that's a global, then pad.y is equal to that value. So for each paddle, other coding languages use for each. In this case, we go for index and value in pairs. Pad y is less than I for a specific paddle, correct. For a specific paddle, correct. Then move to the next paddle and then do it for that paddle as well. So we are moving through the inputs of both paddles and moving them accordingly. Then when we get to updates, we are going through both paddles and checking boundary breaks. And then when we get to draw, we've got two options. We can leave it like this because we know there are two paddles, so this is actually fine. Or, here's the thing, if I now do the for loop here, it's actually going to make this, because this is 2 lines of code. Oops. This is 2 lines of code with a couple of comments. If I add the for at the top and the end at the bottom and then only use 1 line to code the thing, I go from 4 lines to 3 lines. Is it really Is it saving us anything? I mean, it helps for consistency. Just so you know, you don't need to do it here. But might as well. For I and pad in pairs. This some weird spidey sense I've developed from doing this for years is that if I type too much code without running it and checking if it runs, I get like a weird nervousness, like an anxiety that it's going to break. Paddle height stays the same. So, like I said before, if I run this and I did my job, everything should still be the same. Cool. If I use the arrow keys, this guy moves. And now if I press Y and A on the controller, on the other side of the controller, the other two move. Because they're reading off the same code, and those are the buttons that we gave it. So I can theoretically play this against myself if I had the coordination or inclination to do so. But it works. Okay. Next up. Probably to get the ball moving. Right? Because the paddles can move. But there's nothing we can do if... Oh, I need to check whether paddle 2 can boundary break. Boop. Boop. Nope, seems fine. How do we get the ball moving? The ball probably needs to be an object as well, rather than just a rectangle on screen. So I'm going to copy this because we're going to need this. Then ball, for the time being, I think there will only be one. And it'll be an easy change to make if we change our mind. Ball.x, ball.y. And then instead of 4 and 4, I'm going to make a new variable called ball size. Because later on, when we start doing collision detection, it's going to be handy to know how big the ball is without having to ask the ball the whole time. So ball x and ball y are ball size. These are all values that I need to create. So control home. Under paddle height, we add ball size. The reason I'm calling it size is because it's a diameter. It's not height or width. Because if I name it height or width, it's going to get confusing. But if I name it size, it's implied that there is only one size. At least in my mind. This we don't need anymore. Okay, ball size, and then under the paddles, where the two paddles finish, we go. Ball is a table. The ball for now has two values. X, wait, let me just paste that stuff I had from before. X is equal to 118, and Y is equal to 62. 62. Right. Then we need to use this object. We're using this object to draw it. Now we need to use this object to move it. How do we know where the ball is moving? With a paddle, it's easy. Someone's pressing a button, that's why it moves. But the ball needs to move of its own accord. So we are going to introduce dx and dy. This is kind of commonly used for delta x and delta y. Delta being a rate of change in science. So dx we're going to make 1, means 1 pixel per frame to the right. And dy we're going to make 0, which means at this point it means nothing. We do need to check whether the ball renders now that I've changed the draw function to draw using ball x, ball y, and ball size. So run it. Yeah, ball's still there. Right. Okay. And updates. Control O. Go to updates. Update the paddles. Check for boundary breaks. And then after we're done with all the paddles, we are going to move the ball. Now for the time being, this is going to be easy. Ball.x is going to become ball.x plus ball.delta-x. In other words, ball.x at this point is whatever we set it to, whatever the starting value is. And on every frame, every time we go past updates, we add delta x to it. Delta x at this stage is 1, which means each frame it's going to move to the right. Then if we make delta x minus 1, each frame it's going to move left. See? I need to do the same thing for the y coordinate, even though at this point it's not moving. Plus ball.dy. Okay, so if I run this, the ball should move to the right. Okay, let's run that again. Whee! There's no code to handle collision, so of course it's going to go straight through. But we know the ball moves. But I think we stop here and handle collision detection in the next one.